This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 1 of our series, Building Your First Model Rocket, From Kit to Launch. In this episode, titled Introduction to Model Rocketry and Safety, we're going to explore the exciting world of model rockets and identify the key components that make them soar. So, buckle up and let's dive in. A single cardboard rocket can legally share the sky with commercial jets, if you follow rules written by rocket nerds back in the 60s that still work today. You're out in a field, countdown echoing, knowing that behind that hiss and smoke is serious, proven engineering. That launch moment is the flashy part. The quiet secret is that model rocketry is designed from the ground up to be both accessible and systematically safe. You're not mixing chemicals in a garage or guessing how high things might go. You're working with certified motors, tested materials, and flight predictions that can be checked before you even step onto a field. In practice, flying a small rocket is closer to planning a day hike than to doing backyard pyrotechnics. You pick the right trail, launch site, check the weather, pack the right gear, and follow a route others have mapped before you. The surprise is how far that careful structure lets you go. Altitudes that disappear into blue sky, recoveries that land within walking distance, and a clear path from your very first launch to more advanced projects that still sit squarely inside well-understood safety boundaries. You're stepping into a hobby where the numbers quietly back up the thrill. NAR's own insurer sees fewer than 0.6 claims per 1,000 launches, safer on paper than most school sports. That's because every part of the experience is constrained in a good way. Motors are pre-made and labeled by power, airframes are light enough to fail gently, and regulations cap how big you can go without extra paperwork. Within those boundaries, you still get huge range, tiny park flyers that hop above the trees, and multi-stage designs that disappear to cloud height before drifting back under bright parachutes. At the center of this hobby is a simple loop: design, simulate, launch, learn, repeat. Your first step is choosing a rocket that matches both your space and your comfort level. Entry-level kits pair lightweight airframes with modest A to C class motors, giving you enough altitude to be exciting while keeping speeds and recovery distances manageable. You assemble the airframe, attach fins, and add a recovery system, but the engine remains a sealed, standardized unit that you slide in only when you're actually ready to fly. Those letter codes on the motors aren't mysterious branding, they're shorthand for performance. The letter A, B, C, D, and so on tells you the total impulse, roughly how much push the motor can deliver over its entire burn. Each step up doubles that energy, so going from B to C is a noticeable jump in altitude and speed. Below that letter, you'll see numbers and another letter. The first number is average thrust in newtons, and the final letter describes how gentle or abrupt the thrust profile is. That coding lets you match rocket and motor like you'd match a camera lens to the shot you want, not just grab whatever is on the shelf. Layered on top of the hardware is a stack of rules that quietly shape every decision. NAR's long-standing code translates into concrete limits on where people can stand, how far the launch pad must be from spectators, and what kind of ignition system you use. Federal guidelines add a ceiling. Below specific propellant and mass thresholds, you can fly without filing paperwork as long as you stay away from airports, power lines, and other obvious hazards. It's less about bureaucracy and more about giving you a clear map of green zones where you can experiment freely. As you step up in motor size, those same principles scale with you. More altitude means more attention to drift, more careful field selection, and more precise tracking. What doesn't really change is the structure. Pre-rated motors, published performance data, and community-tested launch practices that let you push higher without crossing into guesswork. Your challenge this week: visit a local club's launch or watch a full low-power launch video from countdown to recovery. As you watch, pause and list every deliberate safety choice you can spot: pad distance, launch angle, recovery checks, crowd layout. Then pick one detail and dig deeper. Find the exact rule or guideline behind it, and note how it shapes what's possible in that flight. Think of your first rocket project like planning a short train trip instead of crossing a continent. You're not trying to break altitude records. You're trying to prove you can go from on the pad to safely back in your hands with every step accounted for. A simple single-stage kit and a low-power motor become your test track for learning how choices on the ground echo in the sky, how a slightly crooked fin translates into a lazy arc, or how a different delay charge changes where the parachute appears in the flight. Concrete goals help. For a first build, you might aim for flights that stay well below cloud base so you can track them visually the whole way. Or you might prioritize slow, majestic liftoffs over sharp, high-energy climbs, picking motors that trade altitude for drama. Over a few launches, you start to see cause and effect. A heavier payload, a stiffer breeze, a tweak to the launch angle. Each flight becomes a small, contained experiment, not just a spectacle. Each launch you watch today hints at tomorrow's flight classrooms and backyard labs. Tiny altimeters and GPS units are turning simple arcs into data-rich stories you can graph, code around, and compare online. Like sketching quick field notes before painting a full landscape later. As airspace tools mature, expect apps that show live OK-to-launch windows, weaving rockets into STEM lessons where physics, programming, and responsibility all share the same countdown. As you move from spectator to builder, you'll notice how each choice, paint, payload, launch delay, nudges the story your rocket tells. Treat every flight like sketching a new map. Where did it arc? How did it drift? What surprised you? Over time, those hand-drawn maps become a quiet atlas of your own sky, page by experimental page. Before next week, ask yourself, what specific safety checks will I do every single time before launch? For example, inspecting the launch lug alignment, checking the igniter leads, and confirming my launch site meets the minimum distance guidelines. And how will I remember them consistently? When I picture my first or next launch, where exactly could something go wrong? Like weathercocks in wind, unstable center of gravity, or people wandering into the launch zone? And what will I put in place today to prevent each of those risks? If I had to explain to a friend why using only certified motors and following the model rocket safety code actually makes launches more fun, not just safer, what real examples or stories from this episode would I share? This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!